This is lecture 12 of basic electrical engineering. We are studying loop analysis, and today we will see a circuit with a dependent source. A dependent source is a source which has a magnitude dependent on some current or voltage at some point in the circuit. We will solve this circuit. Here we have a dependent current source whose value is 2kIx. It's a current dependent voltage source. It's a voltage source but its magnitude is dependent on the current in this branch. Therefore, it's a voltage dependent current source. We'll solve the circuit using loop analysis. Right, we can see there are two loops. We'll assume current for both I1 and I2. Are the currents for loop 1 and loop 2. This is loop 1 and loop 2. In loop 1 we have a dependent voltage source. Let's write equation for loop number 1 first. Alright, this current I1 enters from the negative side as voltage, so this means this is voltage rise, and we'll write it as negative as per our convention, minus 2kIx plus 2kI1. It's a voltage drop. It's the voltage drop across this 2 kilo ohm resistor. So this 4 kilo ohm resistor, we know there are two currents, I1 going downwards, I2 going upwards. We will write 4k I1 minus I2 is equal to 0. So we have written all terms for loop number 1. This is the full KVL equation for loop number 1. Right, we can combine like terms together. 2k1 plus 4k1 is 6k1 minus 4ki2 minus 2kix is equal to a 0. Right. For loop number 2, we can write it as equation number 1. For loop number 2, we have to write another equation. We have to write equation for loop number 2. Starting from this 4k resistor, 4k. Here we have two currents, I2 going upwards minus I1 going downwards. The net voltage drop is 4k I2 minus I1 in this direction. This positive, this is negative. Then we have this current entering to the negative terminal of this 12 volt source. Therefore, I write it negative 12 plus the voltage drop across 2 kilo ohm resistor is 2k. There is only one current through this resistor is I2 is equal to 0. So now we can join like terms together, minus 4k I1 plus 4k I2 plus 2k I2 becomes 6k I2 is equal to 12. So this is our equation number 2. So now we have two equations, but there are three variables, I1, I2, but Ix another variable. So we need a third equation. How to find the third equation? Ix fortunately is the same as I2 because it's the current in this second loop. So we'll write Ix is equal to I2. This is equation number 3. Now we are almost done because Ix is the same as I2 and we have three equations, three variables. So let's put the value of Ix where we find it. It's in equation number 1. So put it here, put it here. Now this becomes, instead of Ix becomes I2. This is minus 4k I2 minus 2k I2 becomes minus 6k I2 is equal to 0. So we have modified equation of this, now this third equation. So now we have modified equation number 1. Equation number 1. And equation number 2. I have two variables, two equations. Two equations, two variables. The 6k I1 minus 6k I2. If we take this 6k I2 on the side of the equation, this becomes equals. And this 6k cancels with this 6k. So equation number 1 is just I1 is equal to I2. This means I1 is equal to I2. Putting this I1 is equal to I2 here. This becomes, if we replace this I2 with I1, this is I1. So we have 6k minus 4k I1 is 2k I1. 2k I1 is 12. I1 is 12 over 2k. It's 6 milliampere. And since I1 is equal to I2, I2 is also the same. So we have I1 and I2 the same, 6 milliamperes. And we have to find out the voltage drop across this 2 kilo ohm resistor, which is, according to Ohm's law, 2 kilo ohm multiplied by the current flowing through it. So what's the voltage V out? According to Ohm's law, this must be 2 kilo ohms times the current flowing through, which Ix or I2, which is 6 milliamperes. The 6 milli, so 2k times 6 milli is 12 volts. Kilo cancels with milli, V out. It's 12 volts. That's how we have solved a question where we have a dependent current, we have a dependent voltage source using loop analysis. In the next lecture, we'll find something about super mesh where we have a current source in between, right in between two loops. Thank you.